This video is to review the lesson for exponent rules reviewing negative exponents. This file has it listed as 5.3, but my notes are listed as 4.3 because I use this as Unit 4. These notes come from another teacher who used this with Unit 5, but the content is the same. Here, thinking about negative exponents, if we consider the quotient, so we're dividing here, we have x squared on top and 5x to the fifth power, on the bottom. And if we write this quotient using the division exponent rule, that means we're going to subtract 2 minus 5 and get negative 3. When we write this in expanded form, and then simplify, we get 1 over x cubed. So we should notice that if I have x to a negative power, that will be equal to its reciprocal will have a positive power. So if I have an exponent with a negative in the denominator, if I move that to the numerator, so this is over 1, if I move that to the numerator, then it will become positive. So the way we like to think of this is if I have a negative exponent here, I need to move it across city lines. So our city line is going to be our fraction bar. We're going to move them across city lines to a better neighborhood. So that's the way we're going to think of this. So if we have adding exponents here, because we're multiplying, n to the 0 is 1, and then I have n cubed and n to the negative 2. So if I have 3 minus 2, it's going to give me 1. So I don't end up with any negative exponents for that one, because when we add exponents, we get 3 plus negative 2, and plus a negative is the same thing as minus, which is how I get 1. So here we're moving negative 5 across our city line to a happier neighborhood. So we get y to the fifth. And anytime I have a fraction raised to a negative exponent, I'm going to flip it. I'm going to flip the fraction on the inside. And we can see here that we still use that same idea of if I were to distribute my exponent from the outside to the inside, I would get 6 to the negative 2 power and 5 to the negative 2 power. And then I would need to switch these, and I would get 5 squared over 6 squared. Final answer, 25 over 36. So anytime we have whole numbers should be simplified. Or let's say evaluated, that's a better word. So we need to write any whole numbers to a power need to be written as a whole number. So we don't need to leave that as 5 squared over 6 squared. So here for E, I have a negative 7 here that needs to move to the happy neighborhood. So I get 1 over g to the 4th times g to the 7th, which then I need to add. So I need to understand that sometimes when I have these negative exponents, when I move my variable to the numerator or denominator to change my sign on my exponent, I can sometimes create a product rule that needs to be simplified further. So anytime I have more than one variable, we're going to look at all of those negative exponents and we'll move them opposite of wherever they are. So here I have m to the negative 2, y to the negative 4. So those are going to move up top. I have negative 9 and 27 simplifies to negative 1 over 3. And then I need to combine m's, because I have m cubed and m squared will give me m to the 5th. And then I need to subtract, and I will have 2. This is a 2, not a 7, on the bottom because I have 5 on top, 7 on the bottom. So if I had n to the 5th over n to the 7th, that's n 5 minus 7, which is n to the negative 2, which is 1 over n squared. So it's a 2, not a 7. So pause the video, make sure we have A through F, and all of the additional notes. That's a star, not an X. And then down here for A through F, again, anytime we have whole numbers, we need to simplify. Anything to the 0 power is 1. There's an understood 1 on every variable, so I get x squared on the bottom. Here I just need to switch both of these from numerator to denominator to make that positive. Here we distribute and get -6 and then move this to the bottom. And this is going to equal 1 over x to the 10th, which I believe those notes just might have got squeezed off the page. And here we're going to move this entire chunk to the bottom in order to change this to +3. And then we're going to distribute that exponent. So this is 2y to the 4th. -3 to the 3rd power is -27. 1 times 3 is 3. Y squared to the 3rd power is y to the 6th power. Then we get 2 times -27 is 54. Is -54. It's a negative there. And we get y to the 4th, and y to the 6th gives me y to the 10th power. And then here looking at x, I have 6 on top. That was supposed to be a different color. I have 6 on top and 3 on the bottom. So when I subtract 6 minus 3, I'm left with 3 on top. So that is our final answer. So throwing in the negative exponents just kind of gives us an extra step to make sure that we are dealing with positives only. So let's look at the extra practice page again. So we have some examples here. And this is the same example as the one that we were just looking at. So that's supposed to be a highlighter. My pen is being funny. There we go. So that's the same example. Here we see that we have negative y to the negative 2nd power is going to become y squared on the bottom. So here for example D, in this example, we flipped our fraction to give us +3 right here, and then we distributed. So we could have distributed and then we would have just had to switch. It's going to give you the same thing regardless. So if I come over here and show that if I had x to the -6 over y to the -3, that's the same thing. I just need to flip them in order to have y cubed on top and x to the 6 on bottom as positive exponents. So here when we multiply, we add exponents. So I have -2 and +1 gives me -1. I have +1 and -3 gives me -2. And then both x and y move to the denominator so that we can have positive exponents. So we need to make sure that we are being very careful that the negative out front has nothing to do with the negative exponent. So the exponent only applies to the factor that is directly next to it unless parentheses enclose other factors. So if I do not have, so here I have parentheses, so that's saying -3 times -3. This is saying negative 3 squared. So 3 squared is going to be negative. So more often than not, in our notes, we will see, and my pen is being difficult again. More often than not, if we have a negative on the outside, it will be outside the parentheses. But unless it is inside parentheses, we cannot assume that this is saying negative 3 times negative 3. So if we are missing parentheses, then that's going to give us a negative answer. So we need to be careful about that. So that brings us to the end of our notes for lesson 4.3.